everybody, it's Miss Austin. I'm going to be doing the lesson 10 practice problems. Here we go. Draw a rough sketch of the graph of g of x equals x minus 3 times x plus 1 times 7x minus 2. So we're going to put everything together. We know end behavior and we know our intercepts. So here I know this is going to touch at x equals 3, x equals -1, and then this one, in case you don't know how to do it in your head quickly, it's going to touch at about 2/7. Okay, and then now what's the end behavior? Well, this, if I want to know the leading term, I can do this times this times this. X times 7x is 7x to the third. So it's an odd with a positive. So it's going to be going up over here and down over here. And then I could get the constant, -3 times 1 times -2. -3 times 1 times -2. It's going to touch at 6. All right, let's put all this together. So, 1, 2. I'm living on the wild side here. I'm doing it in a pen. This doesn't have to be perfect. So 1, 2, 3, -1, and then 2/7 is less than a half, so it's like right there. Okay, and then what I do is I know I go to my last intercept over here and I know it's headed up from there. And then I go to my intercept over here and I know it's going down. Then I kind of connect the dots. And I know the constant is 6. So 1, 2, 3, 4, 5, 6. See, I should be using a pencil. And that's got to come back down. How low this goes, I don't know. We're not doing that today, right? Something like that. If I had a pencil, I could do a little bit better job. I'd erase that. Okay. All right, number 2, draw a rough sketch of the next graph. So I'm going to do the same thing now. What does this squared mean? This means it's twice. Today we learned about multiplicity. When a polynomial has a factor 2 times, it behaves in a certain way. Okay, if the factor only occurs once, it goes, or it occurs an odd amount of time, it goes through that number. If it occurs an even amount of time, it bounces at that number. So I know this thing touches at -1 and 4. And behavior, this is x times x times x, x to the third. So it's odd with a positive. So again, it's up over here, down over here, doing something in between. And then my constant is 1 times 1 times -4. So my y-intercept is -4. Let's put this all together. 1, 2, 3, 4. 1, 2, 3, 4. And -4. Okay, now what does this do when it's twice at the same number? Okay, so instead of going through that, it's going to bounce. So normally I go all the way over to my furthest root to the right because I know it's headed up from here. I'm going to dot this to make it a little bit better. And then this one is headed down from here. But because this has a multiplicity of 2, it's not going to go through, it's going to touch and turn or bounce. And then this one would come over here and do something like this. This, I'm guessing. Could I figure out how low this goes? You could. You could pick 1, 2, or 3 and plug it in here and see what you get for an output. But we're just doing a rough sketch. Number 3, technology required. Predict the end behavior, then check. Miss Austin's going to be the technology here, but if you were trying this at home, you could go to Desmos, right? I'm just going to do the leading term. So I'm going to do x times 3x times 4x. X times 3x times 4x would be 12x to the fourth. So So the end behavior is something, the ends are going that way. This is 3 minus x times 3 minus x times 6 minus x. So look, we're going to multiply our x's. So it's negative x times negative x times negative x, which is negative x to the third. So that's an odd with a negative. So it's going up that way and down that way. I guess we could go type these in a minute. All right, this one, I'm going to multiply this. And there's technically 4 x's, right? But it's x to the fourth. And then we got to make the whole thing a negative. This guy does affect it. So negative, we'll just call that negative 1 times negative 3x times x to the fourth. That becomes positive 3x to the fifth. So that's a positive with an odd. So it's something like that. It's going up over the positives. And the bigger and bigger you can get in the negatives, the graph is going into the negatives. And then this, imagine it's going to be this 6 times, if I wrote those out 6 times, right? So every 2 negatives make a positive, so it's going to be positive x to the 6. So it's a positive with an even. So if I looked at this, both ends should be going up. So we could go, well, Miss Austin has a gazillion tabs open. Let's type these in real quick. The first one was x. I'll just do 1 just to show you how you could verify it. X minus 4, I'm doing letter A, times 3x, whoops, minus 7 times 4x minus 3. And my prediction is that both ends would be going up. Whoa, which they are. This graph is sort of, it's Austin's window. Let's see, let's go to 200. It's a little bit better. Maybe down to negative 100. Nope, not quite low enough. Oop, even lower. Oh my goodness, lower. Oh my goodness, lower than 600. Oh my goodness, we're almost there. Almost 900. Bam, finally. Okay, so even though it's doing some crazy stuff in the middle, both of the ends are going up to bigger positive numbers. Okay, you could check all of those on Desmos if you want. All right. Number 4. State the degree and end behavior. Explain or show your reasoning. So if I scan here, the degree is a 4. So that's an even with a positive. So I know, just like we just did that on the last one, I know both of the ends are going into the larger and larger and positive. As x, so the degree is 4. As x gets larger in both the positive and negative direction, f of x gets larger in the positive direction. So you can paraphrase that one a little bit more, because you're saying no matter which way you go, the graph is headed up to larger numbers in the positive direction. Number 7, the graph of polynomial function f is shown. Select all true statements. The degree is even. True, because both ends are together. The degree is odd. No. If the degree is odd, then the ends are going in opposite directions. The leading coefficient is positive. Since both of the ends are down, that means that it had to be a negative leading coefficient. So that is incorrect and that is wrong, or correct. Letter E. So the constant is the y-intercept. So you can see the y-intercept's at 3, so it's positive, not negative. Number 4. Which term can be added to the polynomial expression 5x to the 7th minus 6x to the 6th plus 4x to the 4th, sorry, it's refocusing, minus 4x squared to make it a 10th degree? Okay, don't get confused. The degree is the term with the highest power. You cannot add any of those anyways. They're not like terms. So the only thing that would make this a 10th degree is if there was an x to the 10th in it. So this is the only thing that I could add to that. I could put it anywhere I want, but you'd have to have an x to the 10th. Number 5. Here are two polynomials. F of x is x plus 1 times x minus 6. And g of x is 2 times x plus 1 times x minus 6. Which graph represents which? Well, notice they have the same intercepts. This touches at -1 and 6. So does this one, -1 and 6. That 2 doesn't determine any of the intercepts. But what that 2 is saying is the graph is going to be twice as far away from the x-axis. So maybe, if you could think that through logically, that means the dashed one has to be g. The other thing you could do is you could plug a point in. If you put let's say you were wondering, like, if you put a 0 in, right? If you put a 0 in here, you'd get a 1 times. If you put a 0 in here, you get -6. So when I put a 0 in, it spit out -6. 0, see how that's right there? So that's f of x. Now watch this one. If I put a 0 in here, but I have this 2, look, I have to do 2 times. If I put a 0 in there, I get a 1 times 0 in there, -6. This time I get -12 when I put a 0 in. 0, see that one? So g of x is this one, and this one is f of x. And you could say g of x is 2 times further away from the x-axis. And you could tell that by the number 2 right there. I just put all my work up there. All right, guys. I hope that helps. I'll see you soon.